in terms of buying nitrogen, I would be first of all focusing on using protected urea, but also then I would be ensuring that when they're buying their fertiliser for this first half of the year and for their silage ground, ensuring that they have enough sulphur factored in so that they can apply up to 15 units of sulphur over that April to June period for grazing ground.
I'm Stuart Childs and you're welcome to the Dairy Edge, the Teagasc Dairy podcast. We're bringing you the latest information, insights and opinion to improve dairy farm performance. As part of a mid-term review of the nitrates derogation, a further 10% cut in chemical nitrogen allowances is being strongly tipped as a new measure to be introduced in 2024. That will reduce fertiliser allowances to approximately 200 kgs per hectare or 160 units per acre. This level of nitrogen will not only have to be managed carefully but will have to deliver effectively for farmers. The efficiency of fertiliser applications will be very important. So today I'm speaking with Dr. William Burchill, FBD Lecturer in Soil Science in University College Cork. I started by asking William to explain the concept of whole farm nitrogen use efficiency and how it differs from nitrogen use efficiency in relation to fertiliser applications.
In terms of whole farm nitrogen use efficiency, it is a new metric out there in terms of, I suppose, guiding us as to how efficiently or how effectively any individual farm is actually utilising nitrogen on their farm. When I say nitrogen, that could be from in the feed, some form of feed or in fertiliser. So basically what it does is it looks at the amount of nitrogen that comes into the farm via the farm gate. So what comes in the back of a lorry, what comes in the fertiliser lorry, what comes in the feed lorry, depending on the crude protein of the feed. They'll have the higher levels of nitrogen in the feed with higher crude protein. And also if you're purchasing stock, nitrogen actually comes in and into the farm via the nitrogen in the stock as well. So you can look at what comes in, and then there's a lot of cycling of nitrogen within the farm. And then we can ultimately look at then is the actual amount of nitrogen that leaves the farm in products such as milk and then actually in sale of stock as well. So when we work that through in general, the figure that we see on the ground at the moment from a national point of view for dairy farming is around 25% nitrogen use efficiency. So basically what that's saying is that of all the nitrogen that comes into the farm through the farm gate, only about 25% of it actually leaves the farm then in terms of nitrogen being sold. So the efficiency is at 25% nationally now, and our long-term target really was to try and improve that to up to 30, 35, 40% nitrogen use efficiency. And again, we kind of spoke about that. There's another aspect of nitrogen use efficiency on farms. It's actually the whole area of nitrogen fertiliser use efficiency, the fertiliser itself. That probably has the biggest bearing on the nitrogen use of whole farm nitrogen use efficiency of a farm. So again, nitrogen fertiliser can account for up to about 80% of the nitrogen coming onto our farm. So it's important that we consider this.
Yeah, so you mentioned the feed protein percentage and so forth, and that's subject to some discussion at the moment in relation to maybe having a potential impact on nitrates on farm as well. So we'll leave that aside for today because we'll probably pick up on it in due course in the next number of weeks anyway. So we're going to concentrate on the fertiliser piece. As you said there, William, 80% of the nitrogen use efficiency is kind of falling out the bottom of, depending on the nitrogen fertiliser usage on the farm and so forth. So if we can reduce the amount of nitrogen that we're using on the farm and get a better return for the nitrogen that we actually use on the farm, then that nitrogen use efficiency can improve. So tell me, what actions can farmers take to improve the efficiency of the nitrogen that they spread?
Yeah, so there's the main thing I think that people need to think about is first of all, given the limits that are coming in on nitrogen fertiliser, we have to utilise every single bag of fertiliser that's sprayed and every load of slurry that leaves the yard in the spread. We're going to have to make good, effective use of that if we're going to be growing our 12, 13, 14 tons of grass. Nitrogen is going to start to become limited now, given the change in limits that are coming in. So like one concept that I like to think about when I'm trying to use nitrogen fertilizer effectively is I think what's called the 4 R's of efficient fertilizer use. So that's the getting fertilizer right in terms of the right type, the right place, the right timing, and also the right rate as well in terms of applying the fertilizer. So if we just talk about like the right type, and in this now, especially given this time of the year, like what I'd like to kind of work through is maybe like a shopping list for fertilizer for 2024 and, what needs to be done and what needs to be considered this time of the year. Because often we start talking about this in the middle of next year, the ship might be sailed, the fertilizer is in the yard and we can't change what's in the yard. So like, in terms of the shopping list for going out, getting quotes for fertilizer and purchasing fertilizer now for the springtime and the first half of next year, in terms of the type of nitrogen, look, it has to be protected urea, especially in terms of a cost point of view. It's a lot cheaper than canned fertilizer. And also as well, from an efficiency point of view, protected urea is a lot less prone to ammonia loss compared to normal standard urea. Like normal standard urea, you could typically lose 10 to 30% of that after applying it. So using protected urea safeguards against that. And again, it's ensuring that every grain of fertilizer is going to be worked into the soil and it'll have a lot less chance of being lost. The protected urea, and then like in terms of products with protected urea, I think it's also really important that farmers consider using potassium as well. Like after nitrogen, potassium is by far the second biggest nutrient that our grassland requires for optimal growth. And like potassium is really strongly linked with how efficiently the nitrogen that was applied is actually taken up and utilized by our grass swards. So potassium is very important. Another element as well, and it's often one that's forgotten as well, is using sulphur as well, and ensuring that we are purchasing our nitrogen with some level of sulphur in it, particularly for that April, May, June time of the year. We need sulphur in our fertilizer products at that time of the year, particularly on our lighter soils. And just to give an example of that, there's some recent work that has found almost an extra quarter or an extra 25% increase in grass yield when they applied nitrogen with sulphur versus applying just straight nitrogen. And that was on a very sandy, loam, dry soil type. So there's particular parts of the country on these dry soils, sandy soils, that will get a significant boost in efficiency of their fertilizer when they apply sulphur. Also as well, this definitely comes down to soil sampling as well, is if there's a requirement for phosphorus, that the phosphorus needs to be included, whether it's bought as straight 16% Super P or 18612, products like that. But phosphorus needs to be included if the soil samples and if the nutrient management plan is showing an allowance for phosphorus and a requirement for phosphorus. And like ultimately, like when we look at this, and there's a lot of work in the last number of years looking at how we can improve the nitrogen use efficiency. And like one thing we kind of have to think about is we can't think of nitrogen in isolation. If we want to improve nitrogen efficiency, we have to get P right, we have to get K right, we have to get the sulfur right, and we have to get the lime right as well. So, and even some recent work has shown, like on, even out on dairy farms, they found that, paddocks that have, suboptimal soil fertility, maybe poor for lime, poor for P, poor for K, they may only be getting a nitrogen efficiency of maybe a third of the nitrogen that they applied, maybe 33%. Whereas if you correct and everything's right, if the soil pH is right, P's and K's are in their optimal indexes, we could actually effectively double that efficiency to get up to 66-70% efficiency of the nitrogen fertilizer. So these are things that we can't ignore now, given the restrictions that are coming on chemical nitrogen. And
Just to come back to that now, so at the start there, we spoke about this 25% being the current performance level on the whole farm basis. What's the actual upper level of this nitrogen efficiency from a fertilizer point of view, as opposed from a whole farm point of view, just so that people are clear in terms of what they can expect to achieve here? So you said that we could be as low as 33% there, where soil fertility is offline, but where it's correct, then is there such a thing as 100% effectiveness in terms of nitrogen fertilizer efficiency?
there is, Stuart, yeah, like, especially when we're applying fertilizer during the summertime, when we're getting optimal growth conditions, you can get efficiencies up to 100% at that time point during the year. But kind of on average across the year, you might be talking somewhere close to 70, 75%, when you've got optimal soil fertility, because, you might get slightly higher efficiency during the summertime. Then as you move back into early spring, the efficiency mightn't be as strong, or in late autumn, the efficiency mightn't be as strong. But on average, you'll be talking around kind of 70% efficiency when the soils are optimal. But then if they're not optimal, you're talking about significantly lower levels than that.
Okay, so William, I suppose the easiest nutrient to address for everybody will be the pH piece, right? So you can spread lime at any stage of the year. So if the weather conditions were right there over Christmas, even or over the next number of weeks, people could go ahead and spread lime where it's needed. K, as you said, they're hugely important element, and easily manipulated, I suppose, to a certain extent, in terms of it moves up and down quite quickly, so we can address it very quickly. But the likes of phosphorus levels, not so easily manipulated. So does that kind of consign us to defeat effectively if we happen to have index 1s or index 2s for P? Or can we, by supplying the P either in the form of slurry, or obviously if we have index 1s and 2s, we should have an allowance for P. If we apply that kind of in reasonable proportions, can we achieve that high level return for it, as assuming we put it in, if you know what I mean?
Yeah, and like you said, Stuart, look, phosphorus is very different to potassium. It can move. It's usually a lot slower to move and build indexes, particularly if you have heavy soils with a lot of clay content. There can be a lot of phosphorus, I suppose, absorbed in the soil before you see a lift in the actual P index that you take a sample for. But look, in every case, I think what you need to be doing is, if you are low in index, you just have to start somewhere, and basically, look, whatever your nutrient management plan is telling in terms of the amount of phosphorus that you can supply, ensure that you purchase that amount of phosphorus. Often you will find cases where people won't buy their full allowance of phosphorus. And also as well, I suppose, what we need to do there as well is ensure that we're targeting slurry to the appropriate areas, in particular. And at least if you do that and apply your full allowance and apply your slurry to your lower index ground, at least then you can say that you've done everything that you physically can do to ensure that phosphorus won't limit growth. And I suppose another thing we need to remember as well is that, like, nitrogen and potassium are the big two in terms of actual herbage yield as well. Sometimes phosphorus is obviously very important, but nitrogen and K are the two big ones that are in terms of the quantities that are required for grass growth.
So can you just maybe give me an idea maybe of the quantities of K that are required, William?
Yeah, so for every ton of grass dry matter that you grow, that will typically take up around 33 kilos of nitrogen, about 3.5 kilos of P, and about 25 kilos of K. So you can kind of see the picture that's forming there, the amount of K you take up is not that far behind nitrogen, whereas the amount of phosphorus you take up could be almost 10 times lower than the amount of nitrogen that you take up. And one thing as well that has come in recent years, is when people have been restricted on the amount of phosphorus that they can use. Ultimately, what has happened is that people stop spreading compounds, and that K isn't going out. Do you know what I mean? So that's kind of a knock-on effect of that, unfortunately. So yeah, look, I think that they're very important, and like you mentioned as well, lime, Stuart, and again, like some of the previous and old work that's been done on lime has shown that like where you correct soil pH, you can actually release up to 80 kilos of nitrogen per hectare from the soil organic matter. And I can put that into old money. Like that's up to 2 bags of a 46% protected urea product per acre per year. Like it's an enormous quantity of nitrogen that can be released from the soil where soil pH is actually corrected to optimal levels. And another thing as well is that generally for grasslands we're saying a soil pH of 6.3 to 6.5 is optimal. But for a lot of farmers in the last number of years are trying to incorporate clover. And clover probably is at that 6.5 bracket, maybe even a little bit with it. So, I kind of encourage people to go back and look at their soil samples now this time of the year, pull them out. There might be new soil samples being taken as well. And, if they see their soil pH is at 6.1 or 6.2, and they say, sure, look, that's not that far away from 6.3. But like in reality, if they do want to try and get the maximum use of their nitrogen and maybe are thinking about adopting clover, they need to be aiming for close to 6.5, or maybe even a unit or two above that as well. So, in some cases they might have thought they were at 6.2 and were okay, but there's still lime probably needs to be applied there in those cases.
And I suppose, William, what comes up often when we talk about that is like people get concerned about molybdenum and the risk associated with taking pH too high potentially on a farm. What's your way of dealing with that? Do you really want to drive with the handbrake half on as such in terms of your grass growth potential because of that? Or do you just let it off and try and deal with it outside of the zone of soil fertility, we'll call it?
Yeah. And look, again, and molybdenum is only an issue in certain areas of the country as well. And a lot of farmers at this stage will know themselves whether they have high molybdenum soils or not. And what's the reason why people would be concerned about high molybdenum is that when you increase the pH on these soils, it can lock up copper. But it's effectively what a lot of those farms are doing is they're just supplementing with a little bit of extra supplemental copper via maybe licks or boluses, and that's getting around that issue. And then they're continuing to increase their pHs, increase their dry matter production, and getting around it that way. And it's probably the most economical way to get around it, as opposed to paying this massive penalty in terms of reduced grass growth just because you're trying to manage molybdenum.
Okay, William, you mentioned clover there now. What role does clover have to play in the whole farm NUE piece then, we'll say? Because obviously it's going to reduce the amount of fertiliser coming in, but it's producing nitrogen as well. So how does that stack up, we'll say, in terms of the whole farm nitrogen use efficiency piece?
So in terms of clover, clover will fix its own nitrogen, and essentially it's making the same form of nitrogen that is applied every day in, day out in terms of our chemical nitrogen fertilizer. So we can use clover to replace chemical in fertilizer, and in essence that's can allow us to reduce the quantity of chemical fertilizer that we're purchasing, reduce our input costs. But from a whole farm nitrogen use efficiency, clover will fixed nitrogen from clover is the same as chemical in fertilizer. So it's not in essence really going to improve our overall nitrogen use efficiency, because we're just substituting one type of nitrogen with another. But one thing that nitrogen use efficiency doesn't take into account is that if we can swap fixed nitrogen from clover with chemical fertilizer, we will actually get a massive credit in terms of emissions from agriculture. So nitrogen that's fixed from clover does not have any nitrous oxide or ammonia emissions associated with it. Whereas the second a ship lands in the port of Cork or lands in the port of Dublin with chemical fertiliser, the second that fertiliser is landed in the port, there's a factor applied to it, and it's contributing towards the, I suppose, greenhouse gas and ammonia emissions from Irish agriculture every year.
It's kind of a double-pronged approach. So if we can reduce the nitrogen because of using the clover, we obviously get the benefit there, but also the fact that the nitrogen that we've now taken out and replaced with the clover has no emissions associated with it because it doesn't produce those emissions. We're obviously onto a double win in by virtue of bringing the clover onto the farm as well.
Yeah, that's true.
So I suppose just to sum it all up then, William, and again, I suppose we've kind of I've drifted back in. I won't blame you for that one now. I've drifted back into the Wholefarm piece there, talking about the clover again. But if we just come back to the fertiliser piece, so people maybe not know in the next week, obviously Christmas time and so forth, people will be taking it easy for a couple of days, hopefully. But after that, people are going to be starting to make phone calls about fertiliser and so forth. So what? Just to sum it up, what's the way to approach this for people again? So what do they need to have before they buy fertiliser for the coming year?
So look, the first thing really is an up-to-date set of soil samples. Knowing what P's and K's and indexes they have already, what's the pH of their soils. Then what I would do is, in terms of buying nitrogen, I would be first of all focusing on using protected urea, but also then I would be ensuring that when they're buying their fertilizer for this first half of the year and for their silage ground, ensuring that they have enough sulphur factored in so that they can apply up to 15 units of sulphur over that April to June period for grazing ground. They'll also have to factor in applying up to 15 units of sulphur for first cut silage as well. And also, if they're buying a lot of their fertilizer to start of the year, around 10 units of sulphur for second cut silage ground, okay? So making sure that they've purchased enough sulphur, using protected urea, also as well where there's a requirement for phosphorus based on the nutrient management plan and their allowances, making sure that they have phosphorus there. And phosphorus is particularly important, to be applied, first of all, in that kind of late March, early April period. So making sure that they have enough phosphorus there for around the phosphorus at that time or on the paddocks that require it. And also then, as you go into maybe once you have your sulphur done, then from May, June period, once you get into July, August, I would maybe have something then with a bit of potassium in it. And the reason why I'd be timing that there for that time of the year is that, first of all, there's a risk of grass tetany around this time of the year. And also as well, anecdotally, potassium is actually strongly linked to, I suppose, helping the plant getting through periods of kind of dry weather or stress through to drought. So having a little bit of potassium in with your nitrogen fertilizer can actually help grass growth, in these kind of slightly drier periods of the summer that we've been experiencing the last few years. So that's a major one then in terms of the potassium. And also as well, look, I would just ensure that people are going back now and looking at their soil pHs and ensuring that, okay, is it adequate for grass growth? But maybe the next step need to look at it, is this adequate in terms of a pH level to get clover adopted, a clover established on their farms as well. And the very final thing I would say, Stuart, is if people haven't done it already, is to look at testing their slurry this springtime as well, to ensure that they can maximize the nutrients from within their slurry tanks. There's a free available source of nutrients that's on every farm every year, and testing it can help you to maximize its benefit.
Yeah, and often they can be higher than people actually think. So by adjusting around the numbers, people can get better value from the slurry that they actually have on the farm, or on the flip side of it, obviously, if it's less than what you think, obviously you're not getting the nutrition that you feel you might have been getting from it. So a very important point. And I suppose, William, that's is that something that people should be doing on an annual basis, or if things are pretty consistent on the farm, is once every couple of years good enough to test the slurry, or what's your thinking on that?
I think, sure, once things are staying relatively constant in terms of the same type of stock, do you know what I mean? That the construction or design of the shade or water entering the tank it remains kind of similar. I think a test every 3-4 years would be adequate. And best steps in terms of taking a slurry sample is to do it the first time, to agitate the tank. The first time you're going spreading the slurry, agitate the tank very well. Maybe suck up 1 or 2 loads of slurry, have them spread. Then maybe the 3rd or 4th load of slurry you spread. Literally have a bucket at the back hatch of the tank and get a bit of slurry into the bucket. Fill a container, about half-litre container of slurry, and then it can be posted into any of the soils labs, any of the labs that test for soil samples across the country. Or obviously just send it into or talk to your local Teagasc advisor as well, and they'll be able to just inform you or instruct you as to where you could send it. And a lot of people have made good decisions in terms of upping the rate of slurry application or reducing it based on the nutrient contents. And as well, a lot of farmers, what would have done when they were going out to the tall was to sample 2 or 3 different tanks across the yards, and they were very surprised as to the actual variability in the nutrients across the different tanks within even their own one single farmyard. And invariably what they've been doing then is the tanks with the highest P and K value, they've been holding that and keeping it for their silage ground, whereas the more dilute slurry with a little bit less P and K in it, they've been kind of holding that and using that for grazing platform. And again, when it's more dilute, there's kind of less contamination and cleaner sward as well, which is an advantage in that respect also as well.
Very good, William. So we've covered a good bit of ground there and some very good points there. So effectively, testing is the starting point for everyone. Know what you need, buy what you can, what you're allowed to buy, and put it where it's supposed to go. Effectively is the summation of our last 25 minutes. So thanks for coming on today. Wish yourself and your family and all associated with you happy Christmas and all the best for 2024. And we'll see you in the new year. Thank you.
Perfect. Thanks very much, Stuart.
That's all from this week's episode of the Dairy Edge podcast, and my thanks to William Burchill for joining me on this week's show. Don't forget to rate, review and subscribe to the podcast. You can listen on Apple and Google Podcasts as well as Spotify, and for more information go to the Teagasc website at teagasc.ie. I'm Stuart Giles, and join us next time for your Dairy Edge.